presentation of data. This is the marks of 10 students. This is a raw data. It has not been processed. So this is the marks obtained by 10 students in the mathematics test, like this. By this, can you say, can you find out highest or lowest marks? So as you collect the data, then the investigator has to find something meaningful out of it, something easily understandable, right? So if in this data from here to here, we right now, if you make effort, you can get it. But right now we want a way to present the data. So best way is to arrange these numbers in ascending or descending order. Now when you have an ascending order, or you can arrange them in ascending order, this is the minimum one, 25 is the minimum marks, 95 is the minimum, the maximum marks. And if somebody comes to you and he or she says what is the minimum marks which has been obtained, you can easily say 25. You can say the maximum marks is 95. So by this arrangement of data, you have range also. 95 minus 25, that is the 70, is the range of the data. The range is highest minus lowest. So just by presenting the data in ascending and descending, you have got immense information which cannot be received or observed from the data which is not being in proper form. We'll take one more example. These are the marks of 30 students. 30 students out of 100 marks they have obtained. Now just recall that the number of students who have obtained a certain marks or number of marks is called the frequency of those marks. So this is the frequency. Let us find out the frequency. So let us see how many students have got 70, sorry, 1, 2 and 3 and 4. So the frequency of 70 is 4. Frequency of 70 is 4. Let us make it more understandable, because tabular form and graphical forms, they are always very good to understand. So this is how the marks 10, 20, 36, 40, 50, 56. So we know that how many number of students have got this mark. So may take 60. So 4 students have got 60. So this is called an ungrouped frequency distribution table, because we just simply mark the numbers or written the number, and how many students have got that marks, we just wrote it here. So this is an ungrouped, we are not grouped it, this is an ungrouped frequency table, or simply a frequency distribution table, you can say. And this is the tally marks in preparing these tables. So what can be done if the number of data increased? We cannot go like this. Can we go like this? Even if we are writing 100 numbers, that is as good as writing the numbers like this. Okay? So there has to be some other way. The other way is to group the data. We have 100 plants, each were planted 100 schools during one Mahotsav. After 1 month, the number of plants that survived recorded like this. And in order to present this kind of data, this is very small data as of now, because you'll be dealing, if you are going to become a statistician, mathematics person, then you'll not be dealing with this data. You'll be dealing with hundreds, thousands and lakhs of data. So this is just an example. So we cannot even deal with this 100 numbers data. So we have to group them, and we have to group them just like this, because we see that thing starts from 20, means there is no number which is less than 20. So we cannot start below 20. So let us start with 20 and just mark the class intervals like 20 to 29, 30 to 39. So 29, see 29 is included here. So the lower and the higher limit are included, and we have some one gap also. I'll tell you what it is. 20 to 29 is the class interval, which is having the length 10. So the size is the class size of class width, you can say. So 30 to 39, how many? You just count on your finger, you will find it is 10. So 10 is the class width. The lower is the lower class limit, the higher is the higher class limit. This is the lower class limit, this is the upper class limit, and 20 is the lower class limit, 29 is the upper class limit. So now let us arrange this data in some other form so that you can get a glimpse of this data, or I will not say information right now, the glimpse of that data just by viewing or seeing or watching a table or a figure. So this is a table. Now we start with 20 to 29, then 30 to 39. We have grouped it. Now we just see, let us take the number which is in between. So we have 20 to 29. Let us find out how many numbers are between 20 to 29. So 20 to 29, let us go and see 20 to 29, 20 to 29, 20 to 29, 20 to 20. This is one number. 20 to 29. I may skip some number, but we'll 20 to 29. We'll go back again. So 20 to 29. Let us see this as column wise. 20 to 29. This is 20 to 29. So we have around 3 numbers here. We have to be very precise. These are 3 numbers here. So let us mark 1, 2, 3. 3 bars like this, and write it 3. And you will do it for every other say class interval. So these are the number 1, 2, 3, 4. This is okay. Now when you have to put 5, just make a cross. So this is 5. This is how you have to make. And just if you have the calculated 5 and after that you have some or more entries, you can just mark it like this. But for 5, if it becomes 5, you have to 1, 2, 3, 4 take and make a you have to cross these lines. Now you can just add them, means this is 3. How much is this? 5 plus 3, 8, like this. So if you add these, this has to be 100. Now you see that you just by taking the class interval and having a tally marks and number of frequency, this data has given us some information. Now you can say from this data that we have a group frequency distribution table. This is because this is a group, we have grouped it. So this is a group frequency distribution table, and now we see that we can get the information that 50% or more plants survived in so 50% and more, 50% more. So 8 plus 18 plus 10 plus 23 plus 12. So this number gives you 71 schools. 71 schools, 50% or more plants survived. So you have an information out of it. And these classes are non-overlapping, because see, 20 to 29 we have taken, and then we have not taken 29 till. So we have taken 30 to 39. So there is no, there is a gap between 29 and 30. There is a gap. So this is non-overlapping. And the class intervals can be chosen at your will. Let us now consider this frequency distribution table, which gives the weight of 38 students. 31 to 35, 36 to 40, 41 to 45. So all these have some number, and if 2 new students of weight, say this and this, are admitted in this class, then in which interval will you include them? Now the problem arises is 35.5 lies in between 31 and 35 and 36 and 40. Means 35 and 30, in between 35 and 36, this 35.5 lie. Again 40.5 lie between 40 and 41. 40 and 41, 40.5 lie. So how to add them? So there is a problem. So what we can do here is, we have a very good option. We can take the lower limit of this number, because this 35.5 lies between these two, means 35 and 36. So let us take the lower limit of 36 and 40, this one. Upper limit of 31 to 35, which is 35. Now take the difference. What is the difference? 36 minus 35. This is the difference, so the difference is 1. And just divide the difference, half, 0.5. Now add 0.5, to 35, right? Subtract 0.5 to this, subtract 0.5 with 31, add 0.5 to this 35, and now you can change the class interval. So this becomes 30.5. We have taken 0.5 backward, so now this has to become 35.5. So we have subtracted 1.5 here and we have added 0.5 here. Similarly, for the next one, 36 and 40, we have made it 35. We have subtracted 0.5 from here, that becomes 35.5, and now 40 we have increased to 0.5, that becomes 35.5 to 40.5. So in this way we can just change the class interval. So this becomes 30.5, 35.5, 35.5, 40.5. Now if you want to put 35.5, you can easily put in this class interval. If you want to put any other number, say 40.5, this can be considered, because see, this can be easily inserted here, because 40.5 is included here, not in this interval, because the lower one is always included here. So now you know that how can we change the class intervals also depending upon the situation. So now we have a changed or a modified table which can include 35.5, which can include 40.5 if the need arises, and the numbers become like this, and it has to add up to 40 because total are 40.